Welcome to the Deep Dive. Today, we are undertaking a pretty fascinating mission. We're moving far beyond the simple idea of pets as, just loyal companions.
Right.
We're digging into a stack of source material that really reveals their hidden intelligence, some extreme biological talents, and some truly record-breaking achievements.
Yeah, it's some mind-blowing stuff.
It really is.
Yeah.
If you think you know the limits of what an animal can do, you are about to have your mind changed. So to set the scene, let's start with this relationship between human genius and, well, the profoundly unusual animal muse.
Okay.
We're talking about artists whose inner circles were decidedly eccentric. I mean, think of Pablo Picasso. He had a dachshund named Lump,
Right, Lump.
who even appeared in his famous reinterpretation of Las Meninas, and that was alongside, a collection of owls, a goat, inherited doves.
It was a whole menagerie.
It really was.
Yeah.
And then you have Salvador Dali, who was just, the epitome of eccentricity.
Oh, absolutely. The ocelot.
Yeah,
Right.
exactly. He famously brought his pet ocelot, Babu, to public events. It's clear that this deep, kind of unusual connection has always existed between the artistic mind and the non-human world.
That connection is certainly profound. But the critical insight, the thing we take from this stack of sources, is that potential, whether it's sensory or cognitive, it has to be unlocked by structure.
Structure.
Yeah. We're going to categorize these astounding capabilities into 3 areas. Physical extremes, sensory specialization, and then advanced learned cognition.
Got it.
And for most of the achievements we'll talk about, we're going to see that dedicated training, almost always relying on positive reinforcement, is the key that allows these animals to realize their stunning potential.
Okay, let's explore that intersection of art and structure. We started with pets as muses, but what happens when the pet becomes the artist? I'm thinking of Andy Warhol. He lived with his mother and 25 cats. Started with one Siamese named Hester, then another named Sam, and then named all the subsequent cats Sam. He even published a book about it.
25 cats named Sam and 1 blue pussy.
Yes.
Yeah.
That's inspiration feeding a legacy right there.
Absolutely. But when we look at them as makers, as artists themselves, we really enter the world of operant conditioning. The earliest documented example that seemed to show intent was Congo the chimpanzee. This was back in the 1950s.
Congo.
Between the ages of 2 and 4, he produced 400 drawings and paintings.
400. And the analysis of his work suggests this wasn't just like random scribbling, correct?
That's right. His style was called lyrical abstract impressionism. He showed a really fundamental sense of composition and even symmetry.
How so?
Well, his trainer, Desmond Morris, he noted that if he drew a small shape on one side of a blank page, Congo would immediately balance the composition. He'd make marks on the opposing side.
So it was a conscious effort.
It looked that way. A conscious effort to balance the visual weight. And this convinced a lot of people, including Picasso, who was reportedly a big fan.
Wow.
In fact, Congo's paintings eventually outsold pieces by Renoir and Warhol at an auction in 2005.
That set a pretty high bar. But now we're seeing dogs using their instincts to create sellable art today. We have Van Gogh, the one-eared pit bull mix.
The canine expressionists are a perfect demonstration of how conditioning shapes innate behavior into something we see as culturally valuable output.
So how does Van Gogh paint?
He uses his natural licking drive. The canvas is covered in non-toxic paint blobs, it's sealed in a bag, and then the bag is covered in peanut butter.
Ah, I see.
Van Gogh just enthusiastically smears the paint around while licking, and it generates these really unique patterns.
So the outcome isn't random. This is highly structured. A human selects the colors, the amount, the canvas, and the animal applies the brush stroke, so to speak, through positive reinforcement.
Precisely. And this output can be tremendously valuable. We know one rendition of The Starry Night that Van Gogh did fetched $10,000 for charity.
$10,000.
And then there's Dagger, a lab mix they call Dog Vinci. He uses a slightly more conventional tool. He holds a brush and a specially designed cardboard holder to apply paint to an easel.
The success of Dagger and Van Gogh really teaches us that the limiting factor isn't the animal's ability to participate, but really the human's creativity in structuring that positive reinforcement.
That's it.
Dagger's early pieces sold for $50, and now his commissioned work fetches $200, all benefiting canine causes.
And what's fascinating here is that we've been talking about skills that are entirely learned and shaped, but now we can pivot to the physical and sensory extremes, the biological superpowers that some of these companions are just born with.
That's a great transition. Because before pets can be artists or trick champions, they have
Yeah.
to be these finely tuned biological machines, right?
Exactly. Capable of sensing and achieving things far beyond our own capacity.
So let's shift into that biosensory specialization.
This is tier 2, where we analyze the biological structure. Dogs, specifically, they possess an olfactory system that is just. It's a precision chemical sensor. It makes them essential partners.
How so?
Their sense of smell allows them to detect minute changes in volatile organic compounds, VOCs, that are released through human breath and sweat.
So VOCs are basically chemical signals we can't perceive, but the dogs can.
Exactly. Think of the dog's nose as a hyperspecific gas chromatograph on 4 legs. This is the mechanism that enables them to function as medical alert detectives.
So they can smell diseases.
They can detect the subtle chemical shifts associated with low blood sugar in diabetics, identify the presence of specific cancers, and even alert owners to the impending onset of an epileptic seizure, sometimes minutes before it happens.
These are literally life-saving capabilities. But isn't there still a lot of scientific debate over the reliability of detection dogs outside of, a controlled lab setting?
There is. The skepticism focuses on generalization. Can a dog reliably move from a clean lab setting to a noisy, stressful home? And the research highlights 2 key factors.
Okay.
First, the dog's innate drive for the reward has to outweigh all the distractions, which is a training issue. And second, the success rate is tied directly to the dog's ability to filter information and identify these specific VOCs over and over.
So the potential is there, but the application is tricky.
Exactly. But the documented successes, especially in medical alert services, they really validate their role.
And their sensing goes beyond just medical detection, right?
Yeah.
It touches on environmental shifts we totally miss.
That's their talent as atmospheric forecasters. Dogs often show anxiety or restlessness well before a storm hits because they can sense changes in barometric pressure.
Right.
And they can also hear low-frequency atmospheric sounds, or infrasound, which is below our hearing threshold but travels really far from distant storms. They have a built-in early warning system.
That ability to just tune into the environment is stunning. Okay, so let's move from these innate senses to the measurable extremes achieved through training the world records.
The Guinness World Records really demonstrate the limits of what positive reinforcement can achieve. You look at the Border Collies, Wish, and Halo.
Okay, what did they do?
They set the record for the most tricks performed by 2 dogs in 1 minute 28 distinct sequential tricks. And their trainer used something called progressive reinforcement training, or PRT.
Let's pause on PRT for a second. What does the source material emphasize about that method?
PRT is critical because it moves beyond just teaching a sequence of commands. It emphasizes building confidence, focusing on incremental success, and achieving fluency in the behavior through constant positive feedback.
So it's about the mindset as much as the action.
It is. Wish also holds the record for the fastest 5-meter crawl at just over 2 seconds. These are feats of incredible focus and speed under pressure, which is exactly what PRT is designed to maximize.
And it's not just the classic high-drive breeds. We have an English bulldog, Tillman, a breed stereotyped as, clumsy and low energy.
Right.
He became the fastest skateboarding dog over 100 meters, under 20 seconds. That suggests that conditioning can override what we perceive as inherent physical limitations.
Absolutely. And lest we forget our feline friends, the cat world is keeping pace. Bowsy, an American Shorthair, set the record for the fastest 10 meters on a skateboard by a cat.
How fast?
A blazing 12.85 seconds.
I have to admit, seeing a cat on a skateboard is impressive. And you find out Bowsy's owner, a dedicated trainer, also taught 13 cats to use and flush a toilet.
Now, that's a whole different level of domestic engineering.
It is.
And then moving briefly to just the purely physiological extremes, unrelated to learned behavior. We have superlatives like Smokey the tabby cat.
Smokey
Holds the record for the loudest purr by a domestic cat. It registered a staggering 67.7 decibels. That's about the volume of a vacuum cleaner. Then you have Tigger the bloodhound, who has the record for the longest ears ever on a dog, measuring over 13 inches on one side. These are biological anomalies that make them unique, but they don't necessarily reflect intellect.
Right. That gives us a great view of the physical and sensory boundaries. But now we have to delve into the complex cognitive abilities.
This is where it gets really interesting.
This final section, it fundamentally challenges us to redefine what intelligence even means. Let's start with a canine lexical prodigy, Chaser.
Ah, Chaser, the border collie. She's perhaps the most famous example of advanced vocabulary in non-primates. She understood the names of over 1,000 distinct objects.
1,000.
And this went far beyond simple associative learning, where a dog just hears a sound and connects it with a reward. Chaser's real brilliance was demonstrated through something called novel object inference, or fast mapping.
So if she could deduce the name of a new toy just by eliminating the one she already knew, does that mean Chaser possessed a kind of deductive logic? Like how human toddlers learn language so quickly?
The studies strongly suggest a parallel cognitive process. When Chaser was told to retrieve an item with a word she didn't know, she used logic. I know the names of these 1,000 things, so the unfamiliar word must refer to this one new object.
That's incredible.
And new research on these gifted word learner dogs shows they can categorize objects not just by sight, but by function. They can group objects by commands like pull or fetch, which shows a mental representation based on use.
That sounds like true abstraction. And the source material says this is an extremely rare ability. What specific traits are needed for a dog to get to this level of cognition?
It's extremely rare, estimated to occur in only a handful of individuals, even within breeds like border collies.
So what does it take?
The traits include high curiosity and focus, but the key factor seems to be inhibition, the capacity for self-control.
Inhibition.
Yes. To successfully do this, the dog has to override its preference for a favorite toy or its tendency to ignore a new object just to execute the command. That level of controlled focus and cognitive management is what makes the skill so sophisticated.
Okay, so if the dogs challenge our view of vocabulary and logic, then the African gray parrot, Alex, fundamentally challenges our understanding of abstract thought and mathematics.
Alex, who was the subject of a 30-year study by Dr. Irene Pepperberg, had a vocabulary of over 100 words. He could identify 50 objects, 7 colors, and 5 shapes. This was not simple mimicry. His mastery was extraordinary.
Let's talk about the quantification. What was his most significant achievement in math?
His most profound achievement was demonstrating that he understood the abstract concept of zero,
The concept of nothing.
the representation of absence. He could count up to 6, but understanding 0 is a cognitive milestone shared with only a few non-human species dolphins, some great apes. Alex could correctly answer, "How many are there?" when the answer was 0.
And that implies a highly developed capacity for abstract thought.
Absolutely.
So when people argue that the parrot is just mimicking sounds, how does the methodology used with Alex counter that claim?
The studies were structured to make mimicry impossible as an explanation. For example, Alex could be shown a tray of objects that varied in color, shape, and quantity. He might be asked, "What color is the largest amount of triangles?"
Wow.
Or, "How many red squares are there?" To answer correctly, he had to grasp the connection between the numerical label and the object while filtering out all the irrelevant details.
So he's integrating 3 or 4 distinct abstract concepts to deliver a specific verbal answer.
Exactly. He's making sophisticated categorical judgments and quantifying them. There was one compelling moment where Alex spontaneously started counting his own trainer's finger snaps without being asked.
He's doing it on his own.
He was exhibiting internal abstract calculation.
We started this deep dive with the surprising links between human artistic genius and their eccentric muses, tracing that inspiration from Picasso's Dachshund to Warhol's 25 Sams. We've moved through the incredible training required to turn innate behaviors into commissioned art and world record feats. And we are ending with pets demonstrating abstract logic, complex categorization, and mathematical skills that force us to rewrite the definition of intelligence.
The sheer breadth of talents we've analyzed, from the biosensory acuity of medical detection dogs to the complex language acquisition of Chaser and the mathematical understanding of Alex, it proves that animal intelligence manifests in incredibly diverse ways.
It does.
When you give them the right environment and crucially structured positive reinforcement, these animals realize a potential that far exceeds the old limited metaphor of them as simple machines. That metaphor is fundamentally scientifically broken by this evidence.
It makes you wonder what else we are missing.
Which leads us to our final provocative thought for you to consider.
Okay.
The African gray parrot, Alex, not only learned to count and understand the abstract concept of 0, but he also exhibited self-awareness, a trait only confirmed in about 10 species.
Self-awareness.
So, if an animal can use our language to express complex desires and understands the concept of nothing, what does that suggest about the depth of inner experience and self-awareness that exists in the non-human world? A world we, with our limited human senses and language, still cannot fully perceive or measure.